In this module, we started off by discussing the situations in which you'd want to optimize your LINQ queries. In particular, when you're dealing with very large amounts of data or queries that need to run many times a second. And we also saw that queries containing long-running methods are candidates for performance optimization too. And we saw that there's several options available to you for improving the performance of your LINQ queries, including giving up on LINQ altogether and using regular for each loops. But there are ways you can avoid going to such extreme measures. For example, you can use parallel LINQ or use a LINQ expression compiler like LINQ Optimizer. And as I stressed a number of times, you should always measure performance before and after optimizing to avoid wasting time, and also make sure you have a good suite of unit tests to ensure that the optimized version behaves in the same way as the original version. And one of the major keys to writing highly performing LINQ is to have a good understanding of what's going on under the hood. And this is important both for LINQ to objects and LINQ to SQL. If you've got a general idea of what the cost of chaining on a particular extension method is, then you'll be in a much better position to spot performance anti-patterns before they become a problem in production. And finally, we ended this module with a brief look at performance considerations when your LINQ queries are running against a database, such as with LINQ to entities. And in particular, we saw how you can avoid returning too many rows and too many columns, and also how to avoid running too many SQL queries when just one would suffice. In the next module, we're going to be looking at how we can effectively debug and test our LINQ queries.